All right, back in action here. We're going to do one more sample problem together. This will be for your next set of problems. So the first one, we just did easy mole-to-mole calculations using the mole ratio. And now we're going to start to add in steps as we go here. You'll see we'll get to mass conversions, but first we're going to do from mole to mass or from mass to mole conversions. So we're going to do one sample problem together. I promise it will be enough to get you through. Just listen to the way we talk about the problem. And if I were you, I'd get out a blank piece of paper and do it with me as we go here. So the example problem we'll do for this chapter is actually the exact same reaction as before, so we'll set it up as though we haven't done anything though. If 12 moles of sodium chlorate decompose into sodium chloride and oxygen gas, how many grams of oxygen would be produced? So step one is we always have to go write our chemical reaction. So we know sodium chlorate is decomposing because it tells us that. I got to go crisscross to get sodium chloride, and then we have to remember it's oxygen. So by itself, when we produce that gas, it's diatomic. You can see this problem's a little bit different than our one the other day because I'm given moles and I'm asked to get to grams. So the first thing I gotta go do is balance my reaction. I know I'm doing this fast on the videos, but sodium and sodium are good. I can see oxygen is 2 over here and 3 over here, so that's going to be my main issue. I need to get those both to be 6. So now I have 6 oxygens and now I have 6 oxygens. I have 2 sodiums and 2 sodiums. I have 2 chlorines and I have 2 chlorines. I always like to set it up with my reaction and then I write what I'm given underneath. So I'm given 12 moles of sodium chlorate and I want to get to oxygen, and I got to remember on this one I'm getting to grams. So when it's all said and done, I want grams of O2 on the top of my dimensional analysis. So now I have my bracket drawn. That's what I was talking about with those steps the other day. And I know I'm going to switch from this to this using my mole ratio step. So now I just rock and roll. I'm going to start with what I know. I know I'm given 12 moles of sodium chlorate. That's what I know I was given. And sometimes it'll be different things. It might be grams to start with. We just have to start with what we're given. How am I going to cancel moles of sodium chlorate? I know I need to put moles of sodium chlorate on the bottom. This step right here is where I'm going to use that mole ratio step. Up here I can see in this problem 2 moles of sodium chlorate are equivalent to 3 moles of oxygen. And now I can cancel because moles of sodium chlorate and moles of sodium chlorate cancel out. If I were to stop right now, I'd be in moles of oxygen, which sometimes we might. But if I go look in this problem, I don't want moles of oxygen, I want grams of oxygen. So if I stopped right here, I'd be in moles. I know I need to do one more step to get to grams now. So I got to ask myself, well, how do I get rid of moles of oxygen? I go put moles of O2 on the bottom, and now this is not part of our coefficients. This goes back to our moles chapter. We always know how much 1 mole weighs. That's called its molar mass. A lot of kids are going to want to come put 16 up here, but remember when it's by itself, it's diatomic. So it's 16 times 2, and I can put these two things because they're equivalent. I'm going to keep this as a 1 though, not as a 3, because I'm just talking about the mass of 1 mole here. You're only going to use the coefficients on the mole ratio step. So now, if we're being good problem solvers, moles of O2 divided by moles of O2 cancels out. Since all my units cancel out except for grams of O2, that's what I'll be left with, which is exactly what the problem asked me to get to. And then I just got to take 12 times 3 times 32 on the top and then divide it by 2 on the bottom, and that would give us 576 grams of oxygen. So the main thing to remember, in order to switch, you have to be in moles. If you're not in moles, you need to get to moles. So this was moles to grams. You'll also have a few that go the other way. Get to the mole step, use the mole ratio, and then just be a problem solver and think about what the problem's asking you to get to. Write your reaction, balance it, draw your brackets, and then be a problem solver and get to that mole ratio step. Go get after it on the assignment.